Everyone, in today's video we are going to see about primary batteries. So example of primary battery is dry cell or Lagrange cell. So remember the anode, cathode, electrolyte and EMF. So in any battery or in any cell, if you take anode, cathode, electrolyte and the EMF produced, only these are the four basic points. So the theory or the functionality will be completely same, only these four will vary. You have to remember only these four values. Okay, anode, cathode, electrolyte and EMF. So here anode is zinc, cathode is graphite rod, electrolyte is paste of NH4Cl and Cl2, and then EMF, the maximum EMF it will produce is 1.5 volts. So also remember that where we will place this electrolyte between anode and cathode. Okay, so if it is anode and the outer layer is cathode, we will place the electrolyte inside them, in the space between them. So here in the dry cell, what all we will take and what all we will see is, first one is carbon rod. Okay, this is carbon rod, and this tube whatever we are seeing, okay, that is zinc anode. So here it is anode, and now cathode will be graphite rod, right, this one. Okay, now the anode will be covered with this, like in this way. Okay, and between this anode and between this cathode, MnO2 is filled. Okay, MnO2 here, graphite rod as cathode only, and it will be mixture of MnO2. So MnO2 will act as a cathode only here also. And then after that, this complete anode and cathode are placed inside the paste of NH4Cl and ZnCl2. Okay, in the electrolyte. So now the reactions will take place because of the presence of this electrolyte only. The ions from the anode to cathode will move, and from cathode to anode will move. Okay, I will show it with a real example. So this is a battery. Whatever we are speaking about the primary battery or dry cell is this one only. Okay, it will have positive terminal and this is negative terminal. Now, so you can see here we have one small pop-up or notch kind of thing. This is a graphite rod. Okay, whatever we are using, that one. Okay, in after this graphite rod we have a small circle, right, that is anode. Okay, zinc, and between this graphite and the zinc we have space that is filled with the MnO2. So MnO2 here act as a cathode again, graphite rod in combination of MnO2. And after that we have this outer part, and this is filled with the electrolyte. Now whenever the electrolyte is placed inside this, now cathode and anode will go through the oxidation and reduction reactions in presence of this electrolyte. So, and it will produce EMF. Now if we place this battery in any toy car or in any remote, because of that reactions which are taking place inside this battery, and the toy car will move. This is the functionality of the dry cell. Okay, now we will see the reactions of anode. Then gives Zn plus 2 plus 2 electrons, and at cathode it gives 2 MnO2 plus 2 H2O plus 2 electrons. These are the anode and cathode separate reactions, and the overall reaction is this one. Okay, and also we can balance the equation. This is a balanced one only. Balancing is nothing but we have to make sure that here how many manganese are there, 4. So here also it should have 4. So here it's only 2. That's why. Okay, we have to make sure that we will balance them. In this video I am not telling how to balance. And this is the electrolyte solution. Whatever the NH4Cl we are using, it will take the OH minus ions and it will produce NH3 plus 2Cl plus 2H2. This is the complete reaction. Now whatever the ions released by this electrolyte, it will be absorbed by the zinc anode, and then this will produce the EMF. So the EMF of the cell is 1.5 volts. That means up to 1.5 volts it can generate the energy, or this volt whatever produced is used for toy cars or for the remotes in watches. So these are very small things. Okay, this can be used only where the EMF is very required is very less. So in that cases we have to use this primary cells. Thank you.